So we are going to review linear equations in this chapter 1.2, and this is review, so we're going to be fairly brief about it, but it's important enough because you're going to be facing linear equations a lot in the future, and it's also going to be behind one of the projects that we're about to do. So objectives here are to understand the requirements of coming up with a linear equation, and then you also need to be able to graph those linear equations. Alright, given any 2 points, you can come up with the equation of a line. Alright, true story. If you know 2 points, you can draw a line and come up with the equation for it. So really, someone could pick this point and this point, come up with the equation for a line, and someone else could pick this point and this point, 2 very different points, but they're still going to come up with the same equation. Reason for that is no matter what, this line has 2 things in has 2 very set things, a slope and then also a y-intercept. If you have a line, find 2 points and come up with the linear equation. So did I mention? You better be able to give me an equation for a line if I ask for it. Alright, 2 points, if I give you 2 points, give me that equation. So to do that, I have what we call the slope-intercept form, which is your friend. I've highlighted it and put googly eyes to make it more friendly looking because you really got to know this. M and B are going to be what we need to define in this linear equation. Just like I have the standard form circle equation down here, just like we had to go in and we had to identify a radius and then a center, that H and that K, the center of that circle, those are 2 very set things that will define a certain circle. Same thing with this line, you're going to have to set a slope and then a y value for the y-intercept in order to define a special line. So you may want to pause this at this point to come up with the steps. If I give you 2 points, how do you go through the process of coming up with that line? That y equals mx plus b. First step is to find out the slope, and the slope is just the change in the rise over the change in the run. These delta values, these triangles, are what we call delta y over delta x. Those just symbolize change. So the change in the y's over the change in the x's. And if you grew over the summer, you had change, what would you do to calculate the difference of your heights? Well, you would take your old minus your new height, and then, or your new minus your old, it doesn't really matter. What you would want to do is find the difference, subtract them. So that's that. Once you find your slope, you have part of your linear equation. So to find the other part that we need, the y value of the y-intercept, what you would have to find out is a solution point. If you knew a solution point, which you must because you calculated the slope, then you can plug in the solution point. Now you have your y mx, solve for your b. And so your final answer is going to have a certain slope and a certain y value. Alright, so I did this one in all sorts of goofy order. First, you need to find the slope-intercept form of the equation of the line passing through the points and sketch the line. I plotted my points first and then I sketched the line. And then what we do up here is we start calculating the slope. So I did that by finding the differences of my y's. So here was one of my y values, here was the other one of my y values, so I did y sub 2 minus y sub 1. Alright, just be careful if I went this direction in the subtraction that you remain in that direction for the subtraction of your x values. So you couldn't, for example, do 5/4 minus 1/2 and then do 2 minus 1/2 because you would be going in the opposite direction. So just make sure it's in the same direction, otherwise it will throw off your calculation. So here's some quick review on fractions. If you ever have fractions, since I know some people, Tiffany, like fractions so much, what we're going to be reviewing is a few things here and there. If you're going to subtract or add, you need a common denominator. So what I went ahead and did was I multiplied this term, this 1/2, by the fraction 2 over 2, which of course is just 1. So I've multiplied 1/2 by 1, not really changing it, but changing it enough so that I can subtract them because now I have a common denominator. Same thing with the bottom, I needed to get a common denominator, so I multiplied that term by 2 over 2 as well. Alright, so now I can subtract the tops. So when you're subtracting with common denominators, just go straight across the top. 5 minus 2 is our 3, and then throw that over our common denominator. 1 minus 4 is negative 3, and then over 2. Do keep in mind that this negative could be attached to the 3, or it could be attached to the 2. Doesn't really matter as long as you don't do it to both, because if you attach a negative to the top and to the bottom, you have a negative divided by a negative. You just made that a positive fraction. Alright, so now I have a quick trick. If you have a fraction divided by a fraction, you're going to keep the numerator the same. You're going to change the division into multiplication, and then you're going to change the denominator into the reciprocal, or its reciprocal. So you can see that I did that. I kept the top, I changed the division to multiplication, and then I switched the 3 and the 2 around. So there I have that. Now I cross reduced, and then we finally get our answer, just straight across 1 times 1 over 2 times negative 1, 2 times negative 1, however you want to do it, it's negative because it's positive times negative. What was that? What have I done? Oh yeah, I was calculating slope. So why am I calculating slope? Oh yeah, because I need to find the slope-intercept form. So I have one part of that linear equation. So now what am I going to do? Well, I need to get that other part, that b. So that's where, again, you can choose any x, y solution point. You could have chosen this point right here if you wanted to, or this point. But why not choose one of the points that they specifically gave? So I chose this one, and I plugged the x and the y value. The x was the 2, and the y was the 1/2. Plugged those in so that now I can solve for the specific b that would have this slope and go through those 2 points. So there I didn't do a darn thing, so we'll just go on to the next step. Simplify where you can, because we're trying to get at that b. You definitely can multiply here. So then we can add, and then we're going to get 1.5, or in other words, 3/2 equals b. So just a quick thing, again, like I was saying, is make sure you go in the same direction. So when you line these up, you have a point there. So we have 1/2, 5/4, so that's one of the points. And then same thing here, you have 2, comma, if you work from the bottom to the top, you will have one of your points. That's just, again, make sure you don't swap them when you do the subtraction. And then we can fill in our slope that we found, and then this should be positive. Okay, so there we have it. Alright, so just a quick warning, some data is not pretty. We might have a lot of data that we're working with, and that's what's going to happen in our project that we're going to be working with trends. So what we have is something called a regression line, and I looked that up and used that resource down there. A smooth curve fitted to the set of paired data in regression analysis. That's just a study of fitting a line to data. So it could be a curve, but we're not going to do a curve for this unit. For linear regression, the curve is a straight line. So technically, we do have other equations up our sleeves that could fit this data better than a line, but we're just going to use a line for now. And just so you know, a linear regression is also what we know as a best fit line. Steps to finding the best fit line, you're going to have a lot of solution points. You're going to do a line that fits through them the best you can, and that would be something that you could justify. Why did you draw the line like you did? Well, because it went through all the points, most of the points, or you divided the points up evenly with some plot points on top and bottom. So however you think you can justify it. And then you're going to use those steps that we just did to come up with the equation. So I do have an example of this. And you're going to, there was a bug. You're going to be doing something like this in a little bit. I'm going to just read some parts of my paper that I did. I worked at a company over the summer a couple years back, as it was like an internship, and they had me look at a lot of data, and what they were trying to do was try to figure out trends. So this is exactly, this project that we're about to do is exactly what one business required of me while I was working there. So I'm just going to go ahead and read a summary of that work. Best fit lines, also known as lines of regressions, are lines that are fit to data to make a best possible prediction of the pattern that is occurring. I'm going to skip down here. I analyzed the best fit line for sales of a lever at a company called Merrill Manufacturing. Over the last 10 years, from 2001 to 2011, I wrote out the total number of sales that occurred in January in a data chart. So they gave me a lot of information, but I was able to just look at some of them and whittle it down. So I just picked the January sales over the last 10 years, and you can see when I let X be 0 for 2001, 2002 would have been X was 1, and then there was 1,995 levers sold, and so on and so forth. So in plotting these values, I came up with the following. Here's my graph. I did that on Excel. I chose to draw a line through the point 4, 1,135, and then 11, 1,017. This is shown in figure C below. I'm going to just show you that. It's the same exact blue line, but I have my best fit line through it. This was the best fit line I chose because it put a line to evenly divide the data plots on top and on bottom. It fit to have 4 data plots above and 4 data plots below it, so it averaged out. So there's my justification. And then what I went ahead and did was I calculated the slope of it, and I kind of analyzed what it meant. And then I plugged a point in to figure out that B. And so now what I can do is I can come up with the equation for a line that I could use and plug in, let's say, the year 2015, which would have been x equals 14. So you can see I plugged that in. And I calculated that in the year 2015 they would be selling 937 if they continued on the pattern that they were at. So prepare to do something like that. I will see you tomorrow.